Okay, this is Leetcode 117, populating next right pointers in each node. That doesn't say much. But yeah, I saw this problem a few days ago and I couldn't solve it. Yeah, I was just kind of stuck mentally. And I probably should have spent more time kind of thinking about how I would implement it, but I decided to move on to another question. And it was good today because I tried to revisit it and I came up with my own unique solution that I think is easy to follow and it beats, I think it was like 75% of other people on Leetcode in terms of runtime. So the question is, you're given some sort of tree structure, right? 1, 2, 3, 4, 5, 7. And these nodes that they give us the node class already and kind of what attributes each node class has. So there's like a left, right, like every other kind of node class that you've seen, but it also has a next variable, next attribute. And that next is initialized to none at first. And what we want to do is have, for each node, the node to its right should be its next node. So for example, when we have this node structure, obviously the left of 1 is 2, the right of 1 is 3, the left of 2 is 4, the right of 2 is 5. 3 doesn't have a left child, so it's none. 3 has a right child, so it's 7. And then our next pointers, or next attributes, should point to every node in at the right. So there should be none. 1 doesn't have 1, 3 doesn't have 1, 7 doesn't have 1, right? And then they want you to return the root. So yeah, that's the question. And I spent a few minutes kind of thinking about how I would do this, and the first kind of thought that came to mind was, why don't we store these nodes into an array based on the depths, right? So I'm circling it because it's a node class, not just a value. What if we stored it like so, based on the levels of the tree? Right, this is just for visualization. So what if we had something like that? And then we had references to these nodes, and all we needed to do was iterate through these, iterate through the length of our arrays here, -1, and then just say element at I, point to element I plus 1. Element I, element plus 1, plus 1. And then at the end we could just return our root, and then that's exactly what we have. So that was like the most simple solution that I came up with. And when I ran it, it ran perfectly well. So yeah, let's try that approach. And also, when I'm doing these, I'm not kind of looking at any answer. I'm just either, sometimes I am kind of remembering my solution, but I'm really trying my best to solve it on the whiteboard, just based on like conceptual understanding instead of memorizing. But yeah, so let's do that. I use kind of a similar solution to when I make something like this. I use like a default dict and then just some tree traversal algorithm that's pretty easy to do just based on the depths. So let's do that. Let's create this dictionary first. And this is a dictionary because, right, these are the values that I wrote. Key should be the depths. The depths. Depths. Define, create, create depths. Right, takes in root that we're starting at, dictionary that we're updating, and the depth that we're currently at. Not root. And we return. Don't do anything. Else, we'll say D with depth. Let append. Root. The entire root, not just the value. Create depth. Recursively call this function. Root left. D depth plus 1. Same thing. Right. D depth plus 1. So now we have this, right? And our main function would just look like this too. Don't have that yet, I guess, but we would have this when we call this function. Main function would just take in the root. Yeah. D is equal to default. Date of a list. Create depths. Guess I could have named that better. Root D 0 starts at 0. So now we have this. What do we want to do here, right? So we want to go for nodes in d.values, right? So we're looking at this part, just the values, that column. And we want to go over the indices, not the nodes itself. Because if we just get the reference to the node, how are we going to point it to the one over? Can we do that? No, I think you're going to need an index. So for IDX, we can do I, but I think IDX is more verbose. And range, and we're going to do -1 because if there's length of 2 here, here this thing is not going to be pointing to our next element. It's going to be next out of bounds. So length of nodes -1. All we need to do is nodes at IDX dot next is equal to nodes IDX plus 1. That's it. Boom. It's going to go here. Length of the nodes is 0, or 1 minus 1 is 0. Don't do anything. Go here. For nodes 2 and 3, IDX in length of 2 minus 1. So we go here. Nodes.idx at 0 dot next. So 2 dot next is going to be pointing to nodes on IDX plus 1. So we just did this. This is there already because it's defaulted to none. And then we go to here, same thing. We do this, and then we move to the next one. We draw this, and then this one defaulted to none. So all we need to do now is return root. Boom, that's it. It's that simple. That's what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 lines of code. Could have done this in one line. Yeah, I mean, I hate when people just write everything in one line and use a lot of list comprehension because it's just hard to read. I understand sometimes the list comprehension is like the way to go, but yeah, I think it's a lot more easy for the interviewer to read and also you to kind of understand. So this is how I just always do it. So yeah, there's that question. Thanks for watching.